Friends, today let us discuss the statistical mechanics. Statistical mechanics is a branch of physics which tries to predict the overall properties of a system of particles by studying the statistics of individual particles constituting the system. So we are trying to predict the overall properties or behavior of a system of particles by studying the statistics of individual particles constituting the system. With the help of statistical mechanics, we can explain properties, the thermal and electrical properties of solids, magnetic properties of materials, properties of different stars, different types of stars, black body radiation, and many properties of many other systems. The name statistical mechanics, it implies that it is not concerned with the actual motion of or interaction of particles. The term statistical, that implies that it is not concerned with the actual motion or interaction of the particles, but instead with what is most likely to happen. What is most likely to happen? Most probable thing to happen. Now, what the statistical mechanics does is, as we said here, it determines the most probable way in which a certain total amount of energy, capital E, is distributed among n members of a system of particles in thermal equilibrium at temperature T. So we have a system of large number of particles which is in equilibrium at a temperature T. And in statistical mechanics, we try to determine the most probable way in which a total amount of energy E, is fixed. This energy is distributed among capital N members of the system of particles. So we have many single particle states. These are the states possible for a single member, a single particle of the system. We have G1 states having the same energy epsilon 1, G2 states having the energy epsilon 2, G3 states having the energy epsilon 3, and so on. And the total energy E is distributed among capital N particles having the single particle states like this. So in this, N1 particles will be in the state of energy epsilon 1, N2 particle in the energy level epsilon 2, and 3 particles having energy epsilon 3, like that. Here this G1, G2, G3, these are all degeneracies. The number of states having the same energy. So all these states have the same energy. There are G1 states having the same energy. Here we have G2 states having the same energy, epsilon 2. So this number N1, N2, N3, this is called a distribution of energy. This is called a particular distribution of energy. And many such distributions are possible because the only condition is the total energy E is equal to N1 epsilon 1, N1 particles in the epsilon 1 state. So N1 epsilon 1 plus N2 epsilon 2 plus N3 epsilon 3. So when you take this sum, you get the total energy. So this is fixed, but this N1, N2, N3, these can vary. Okay, and a particular set of N1, N2, N3 is called a given distribution of energy. Now W, a function of N1, N2, N3, this is called the number of different ways the number of different ways in which the particles can be arranged among the available states to yield a particular distribution of energy. So this is called a particular distribution of energy. Now W, that is actually the number of different ways. For a particular distribution of energy, the number of different ways the particles can be arranged. The particles can be arranged among the different states to yield a particular distribution of energy. This is actually called the number of microstates. So this is the number of microstates. So we have to be very clear about the distribution of energy. This is actually this only specifies the number of particles in the first energy level, second energy level, third energy level, fourth energy level, so that total energy is this. And for a particular distribution of N1, N2, N3, N4, etc., the particles can be arranged. They can be arranged. They can be there can be permutation of the particles to give a number of states for a particular distribution of energy, and this is called the number of microstates. Now, statistical mechanics actually is based on two postulates. The first one is all these microstates are equally probable. All microstates are equally probable. Okay, so microstates are equally likely to occur. Their probabilities are same. So that is the first postulate. The second postulate is greater the number W. We saw now W is a number. Okay, greater the number W, that is the number of available states for a particular distribution of energy, the more probable is the distribution. So greater the W, the more probable is the distribution. So there are different distribution possible. The most probable distribution is the distribution for which this W is maximum.